So, point to point communication. So, what does it mean? One processor talks to another processor, point to point. So, there are collective communications which are like everybody is involved, okay. So, that will come later, and there is a reduce operation. There are three types: point to point, reduce and collective. So, let us look at point to point. So, block send and block receive, right, we did it before. So, block send means I had made one mistake when I looked at it. So, blocking typically, okay, there may be some implementation which is different. Blocking means you are blocked till when? Till the job is done is locked. So, block send means until the data is received by the receiver, okay. Until the data reaches the receiver, you can't do anything else, you are blocked. Similarly, the MPI receive is blocked until data comes to it, okay. So, the receiver is saying that I want to receive, but will say, well, by the time I receive, can I do something else? It turns out blocking does not allow anything to be done, you just wait, okay. So, that is blocking. So, the data is flowing from the memory to buffer, and it goes there and there and there. So, I had said earlier in my Python lectures that as soon as this buffer is emptied, the MPI send can continue to do something else, this rank. But it turns out, well, I mean, there are some documents which say no, and I do not know how to test it, okay. So, this data will flow from here like that. Until this happens, this MPI send will not be complete, and this processor will not be doing anything else. And the receiver, so this guy is saying receive, no. So, until the data is copied into that memory, receiver this is not doing anything. So, this is for large data, it may be big weight, and for the processors, in fact, it is a waste of time. The guy can do something very lot of computation. So, blocking is typically not preferred, okay. So, if there is something which can be done without this data, that some data is required here, no. So, if without the data, if something else can be done, go ahead and do it, okay. So, that is not non-blocking, okay, that is called non-blocking. So, blocking one has a syntax. So, blocking send is, as I said, it will just wait until the data is received. So, this is just what I said before, okay. Receive is waiting until the data is copied on the data block, okay. Of course, it uses a buffer. So, but there are now ways to avoid the buffer. You can send data straight from memory to memory, okay. But we are not doing it here, but this is very fast, okay. NVIDIA GPUs allow that memory to memory copy. This is also called synchronous send and receive. You sync. So, the syntax is the name of the function is MPI send, and this is where the data will be stored with you are sending a pointer, okay. So, this says I need a pointer, count how many data type, integer, real, whatever, destination where it is going, tag and com. So, you have 6 arguments. In Python, if you recall correctly, this was not required, and this was also, I believe, not required, okay. So, from the variable itself, the interpreter knows what kind of data is it, okay. So, Python is well, I mean, lot of arguments are ignored or not required, actually I would say. And MPI receive is similar, except we have new thing called status. So, this we have seen it before. Status has some flags which tells us whether thing has received or not. Also it has data size. So, this status is an interesting variable which has some more information. We can do both together in one function, MPA send receive. So, you have to give what data to be sent and where to send and what data will be where will it be received and who will receive it. Okay. So, you can combine the two. So, this syntax you need to see. Okay. You need to worry about this one. So, I am going to show you some example status, actually basically for blocking this is important, for this for non blocking anyway that guy is waiting. So, status is not very useful. Is for debugging, but I do not expect you to do debugging with status. So, tag we discussed before. So, suppose I send two sets of data from same processor, same sender is sending two packets. So, packets is good idea to label them, no? What is what, otherwise the example is username and password. So, we do not know which one is password and which one is username. So, the tag can tell you that this is password and this is user name. Okay. So, we discussed it before. So, I am not spending too much time on this. So, unique identification for a message. This is useful when same sender is sending two packets to same receiver. So, his status is for indicating source and tag is a pointer, and for example, his stat.mpa source. So, you can find out who is sending it, and tag also is there. So, status has lot of information, okay? And these are various data types. So, I can't say just int. So, data type will be MPI int, MPA long. So, you need to write these kind of keywords. Okay. You can send complex. You can see you can send lot of different types of data through MPI. So, this example is not indented properly. Of course, C does not mind any kind of indentation. Python would have objected. You should have asked for 4 or 2 spaces, right, indentation. So, what is it doing? If rank equal to 0, that means is rank 0 is also called master processor. So, master is going to send what? So, this part of the code. So, this bigger code is there in Colab. So, I am sending out message is a character of size 1. So, simple character, it could be A like this, okay, and its tag is 1 and I forget what they are, destination. So, this is a destination. So, going to rank 1, tag is 1 and the communicator is standard COMWORLD. If rank is not 0, I am using only 2 ranks. So, that should be 1, or you may write if else, if rank is else if, okay, you can write that, but right now there are only 2. So, I know that if it is not 0 then it is 1. Then I receive, so message, size, character, this is any source. So, I receive from anywhere, it is not telling me which source, okay, and any tag does not care, and communicator and stat, and then print. So, I do not care about stat here, I just print what I am receiving and what I am sending. So, when I execute this one with 2 processors, I get this processor 1 received, processor. So, this is rank, okay. So, received character from processor source, okay. This source is going to give me, oh yeah. So, stat I am using it right now, stat is going to give me source, okay. So, source is here, source is here, okay. Is that clear? So, this is the send receive is blocking until the work is done, it is not going to do anything else. Non blocking. So, non blocking means it will wait, sorry, it will not wait, not blocked, no, when you are in the road you are blocked. So, this is non blocked, you send the packet and you do not need to wait for it to complete, you can do something else, okay. So, it is possible. So, for example, in your parallel computation you have big array and I have finished working on one column or one slab. Once I am done, I can send it to somebody else for some other operation and I can start working on the second column, right. So, I do not need to wait until this data is reaching the receiver. I work on this, then once I am done I send this like that. So, I think blocking is non-blocking is what people use typically, and the name of the function is different. I send and I receive. Okay. So, it returns immediately even if the communication is not finished. I send I receive method returns request instance. So, this is an important thing. So, the request will keep track of whether data is reached or not reached. Okay. This for tracking, blue dot tracking. Okay. So, this is what this request does that. So, request dot wait. So, I am going to show you the example later after you send it. So, there will be I send, then do something, then I say request dot wait. So, request will be one of the argument for this. So, this request will be waiting when I start my other work and I need to proceed for the next set of work. So, this is called like synchronization. No? So, I want to know that everybody is finished or not. So, that is done by wait. So, this will synchronize. In fact, you say often I need to say is the work complete or not. If not, then I wait. So, this is what is doing it here. Okay, we can overlap communication and computation here. Okay, this is a reference. This is syntax. Okay, so the new thing is this request pointer. So, MPA wait has a particular syntax. So, you have to put request and status you can ignore. Okay, so let us look at this code. So, string copy. So, if rank is 0, then I string copy. So, basically create a string. For Python it was very easy, right. I said x equal to this, but here in C it is not, I cannot say str equal to 0 to 1, even though str may be a character string. So, this is the function I need to use str copy. As for standard C, this is what we do. So, this will copy there. So, string is now is carrying that variable 0 to 1, or carrying the string, not variable, carrying the string. So, MPA send, I send the string, and size of string I can send maximum 10. So, I just put 10, it works, 10 works. So, some blanks are being sent as well. Okay. Is character to 1, tag 1 is the tag is, well, I think I made a mistake. I think this tag should be tag cannot be written like this. So, this should be just 1. Tag is an integer, so it can't be done like that. And MPA com world and request. So, this is the request. This is important. The request is additional feature in asynchronous send or non-blocking send compared to synchronous send. If rank equal to 1, then I receive that same, the same variable, with this could have been different variable, but you declare all the variables. So, str was declared before character string. So, size 10 character. So, this tag is 1. So, it is coming from 0 and request. By the way, this request and this request are different. Why are they different? No, well, that is not because
that one is for the rank 0 and this one.
Precisely. So, this for rank 0 and this for rank 1. So, I had to I had to declare this variable request request. So, everybody has a request, but I am not reusing it. Everybody is using their request, but they are different. Okay. At this point, I can do this will initiate send and this will initiate receive, but then I can do something else. After this, I need to wait for the work to be completed, this send and receive. So, MPI wait request and start. So, the sender will wait for this request to complete and receiver will wait for this request to complete. Okay. And once it is done, then so rank 0 says well not sending, I sent, processor sent. So, the work is done and this is received. There is a better word, no, because the work is complete. So, rank 0 said I sent this and rank 1 says I is not a proper word, because output will come in the printer or in the screen. So, we will say processor 0 sent it and processor 1 received it. So, this is how it will work. So, yeah, 0. So, message is the same, okay, 0 to 1. So, this was same Python code. Well, Python code had exactly same function, it had next number of lines, and we achieved this one. Okay.